Welcome to Algebra 1, Semester 2, Unit 9, Section 10.5. This is completing the square, and I just want to use algebra tiles for a minute on these. You'll see the problem in your notes is x squared plus 8x equals c. Now, if you remember from class, we could build that expression with our algebra tiles, and it would look like this. It would be x squared plus 8 of these x pieces. Whew, they barely fit in here. Okay. So this technique is really handy, and you'll see why here in a minute, but we call it completing the square. And what we do is we take this expression and we literally build it into a square. So in order to make that a square, I would pull half of those. I'm trying to watch my screen here and make sure that I don't get it off screen. I would take half of those x's and move them around to the other side of my x squared. And now, I'm going to go almost off screen. I'll push it up so that you can see the bottom part of it. And now all that I need are the little pieces, you know what they are, the single digits, to fill in right here to complete that square. So once again, we took the x values and we cut them in half so that we could get a square just missing one little section. And now we can fill in with these little pieces and end up with a completed square. In class, feel free to get out the algebra tiles and build a few of these. Your brain really does remember doing this activity, and you can really actually think through it easier that way. So, we just completed that square. All that we had to do was add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to that. So, the c value to complete the square would be 16. Let's look at the next one. The next one is x squared with a minus 12. So if we build that, we have the x, the minus 12, see if I have enough tiles here. I'm sure this won't fit on the screen this time. We'll do our best. There's 6, 7, 8, 9. But if we had 12, half of 12 would be 6, correct? And so then we would bring our 6 down this direction. And the question is, how many would we have to fill in here? Well, if it's 6 this way, and it's 6 this way, what could we do to get that? We could multiply that, and that would be 6 times 6, which equals 36. So our c value is 36. Well, if we look back at the pattern, remember math is always relationships and patterns. We took the 8 x's, we divided by 2, we got 4, and then we squared that, made a square out of that, 4 by 4 to get the 16. So here, even though we ran short on tiles, you were still able to reason it, and you took half of 12 That was negative 6. You squared that, made a square out of it, and that became 36. Didn't matter that it was negative or not. So here, I'm not going to cut my tiles for you, but we would take this, we would take the 3, same thing we've done on the other problems. We take half of it, and then we square it. Well, what's 3 times 3? 9. And 2 times 2? 4. So there's our C value. 9/4. That's called completing the square. Now you can actually solve problems. We're going to practice that quite a bit when you come to class. Here's some of the problems we're going to look at solving. So in order to complete the square, we have x squared minus 16x. Well, we would take half of that b value, so negative 16 divided by 2 would be negative 8. And now we square that. So we get negative 8 times negative 8 is a positive 64. What we do to one side, we have to do to the other. Now we can rewrite that problem. X squared minus 16x plus 64 equals 64 minus 15 is 49. Now here's what's really nice in solving this. Keep this little note written down to yourself because this is a perfect trinomial square. So when we come down here to factor it, the two factors will be identical because we know that it's a perfect square. We know that it was 8 minus x, or 8 minus x minus 8, on each side. If you think back to building that, it would be 8x minus 8 times x minus 8. We don't write it twice in our problem. It's easier to just go straight to the x minus 8 squared. And you can get that from right there, or you can get it from thinking about the square that you've built. Equals 49. Now we're ready to solve. First step is to get rid of the square. We do that by square rooting. That will cancel, and we get x minus 8 equals plus or minus 7. Now we add 8 to each side, so we find that x equals 8 plus 7, or x equals 8 minus 7. 8 plus 7 is 15. 8 minus 7 is 1. So those are your two answers. That's where it's crossing the x-axis. Okay, now we have our next problem. It's worked very much the same way, but on this one, the first thing that you would need to do is factor out a 2, because 2 will come out of all of those, and your goal is to have this x with a 1 in the coefficient, the x squared with a 1 as your leading coefficient. So factor out 2. We get x squared plus 10x minus 4 equals 0. Okay? Now we can take it into looking just at this part of it. Plus 10x minus 4 equals 0. Okay, that's as if we divided each side by 2. So now we want to complete the square to answer this. X squared plus 10x. Well, if we complete the square, we really don't want that 4 there. So to get rid of that, to eliminate that, we would add 4 to each side. So we have a 4 over here now. Now, what number do we need to complete the square? Well, we take 10, divide it by 2. That would be 5. and now we square it. That would be plus 25, plus 25. So over here, we go ahead and we add that in. 4 plus 25 is 29. On this side, though, we go straight to our square. What was the length of the side of that square? Well, we had taken 10x and divided by 5, or divided by 2, so we got 5. So we have x plus 5. Okay. Now to get rid of that square, we take the square root. What we do to one side, we have to do to the other. So we end up with this canceling. We get x plus 5 equals plus or minus square root 29. Subtract 5 from each side. We get x equals negative 5 plus or minus square root 29. That is a real answer, and that is a good answer. Okay? So that is the end of that section. Thank you very much. We'll see you tomorrow in class. Let's practice with the algebra tiles to begin with.